Hello students, I am back again, and today also we will be solving problems from electricity chapter. And what I want you to know is you should have the formula list which I had given in the last class. Make sure that you have that with you. We will be using it and we will be solving problems related to especially series and parallel combination. Okay, so let us start. Next, let us solve problems related to Ohm's law and the resistivity. So here I have written the formula. Let us read it carefully. So we have how much current will flow through a resistor. So you have to calculate how much current, that is I you have to calculate. So I'll write solution. So I you have to calculate through a resistor of resistance 10 ohm. Resistance is given, so R is equal to 10 ohm. From a source. Now here, what do you mean by source? Source means battery. Okay, source means cell or battery. So here V is equal to 220 volts. How you come to know all these things, symbols? Look at the SI unit. This is ohm, so it has to be resistance. This is volt, so this has to be V. Okay, so current you have to calculate. Now look at the data given and see carefully how you can connect them. So consider, again make sure that whenever you write a formula, write something. Consider, hence, we have, or let, all those things you have to write. Okay, don't just write the formula. Well, it is correct, but when you write the sentences, it looks nice. So always do that. So consider Ohm's law. Okay, I consider Ohm's law. Equation I will write. When I'm not writing the Ohm's law statement here, whatever equation I have from Ohm's law, I'm writing that. Okay, so V is equal to IR. So V is 220, I will substitute, is equal to I. I have to calculate I. Okay, so I will write as it is. R is given 10. So 0, 0 you can cancel. So your I will be 22. Again, if you just write 22, it won't have any meaning. Whenever you write any physical quantity, there is a number followed by a unit. Okay, so it will be ampere. So this is problem number 3. Next, I have problem number 4. That is, a metal wire has length 10 centimeters. Now here you have to be careful. A metal wire has length 10 centimeters. SI unit of length is meter, but it is given in centimeters. Okay, so L, let me write solution. So length L is 10 centimeters. 10 centimeters means how many meters? How do you convert? Okay, so 10, to convert from centimeters to meters, you have to divide by 100. You have to divide by 100. 10 by 100 is 0.1 meters. So always remember, SI unit of time is second, SI unit of length, radius, diameter, breadth, width, all those things are meter. So always make sure that they are in meters. So L, I got it. Next, and has a resistance of 20 ohms. So resistance R is given 20 ohms. Done. Next, if the radius of the wire is 1 mm, what do you mean by mm? M means millimeter. So this is the radius. They have mentioned radius of the wire is 1 millimeter. So R, so now I will take it as small letter r. I will use small letter r for the radius, capital R for the resistance. Don't use same R. If you use a symbol, don't repeat it. Okay, don't repeat it, you'll be confused which one to use and it will give you wrong answer. So please be careful, you use different symbols. So radius R is 1 millimeter. So I have 1 mm. Again the question is, how do you convert this to meters? See, well, there are two ways to do it. One, you can see, to convert from centimeters to meters, I divided by 100. The radius, which is in millimeter, from millimeter to meter, what you have to do is, you have to divide by 1000. So it will become 1 by 1000. When you divide by 1000, 1 by 1000 is 0.001. Okay, 0.001. You can verify this. You can just use your calculator also. You can verify whether this is true or not. Meter. So this is my radius, this is my length, and this is my resistance. What they are asking, what will be its resistivity? So L is equal to 0.1 meter, that is 10 centimeters, and R is equal to 1 millimeter, that is 0.001 meters. Okay. So again I have written whatever calculation I had done, I had written it here. You can write it directly. If you know how to do it directly, you can do it, no problem. But here, make sure that you have units carefully. Okay, done. So which is that formula which will relate length, radius they have given, resistance, and you have to find resistivity. So we have the formula. So we have R is equal to rho into L by A. Now what is A here? A means area. So L means length, which we have. R is resistance 20, we know. A, what is A here? If you consider a wire, see they said it is a wire. If you consider a wire and if you see from the side, it will look like a circle. So area of circle is pi r square. It is pi r square. Okay. So let us simplify. I have to find resistivity. So I will rearrange this equation. So resistivity rho will become R into A by L. R into A by L. Now what I do is I will substitute. My R, capital R is 20. My capital R is 20 into, I have A. A is pi r square, I had written. A is pi r square. So it will become 3.14. So pi is 3.14. Remember, pi is 3.14. R square. So R is 0.001 meter. R is 0.001 meter. When you square it, what will happen? So for that, there is another way to do it. Okay, so pay attention, there is another way to do it. So whatever I have R square there, now here R means 0.001. So you should square it. So if you can square and write, it will become 0.0000. So many zeros you get. Instead of that, what you can do is this 0.001 can be written as 10 power minus 3. 10 power minus 3 means milli. Okay. Milli means 10 power minus 3 square. So 0.001 means 10 power minus 3. Why 10 power minus 3? Because after decimal you have 3 places. So what you are doing is you are shifting this decimal to the right hand side. Since you are shifting the places by 3, it will become minus 3. If you had one more, it would have become minus 4. Okay. So I have 10 power minus 3 square. 10 power minus 3 square is nothing but, so whenever you have a power m whole power n, it will become a power m into n. Means you have to multiply these two when you have power of another power. So here what I have to do is I have to multiply these two. It becomes 10 power minus 6. So our R square answer is 10 power minus 6. Be careful. Okay. So I will be writing 10 power minus 6. So this is the calculation part. How do you get this 10 power minus 6 for R square? Okay. Divided by L I have. So L is 0.1. Just like how we had written this 0.001 as 10 power minus 3, we can also write 0.1 as 10 power minus 1. You can do that. Okay. It is not wrong. You can do that. Now here when you simplify, what will happen? So this 10 power minus 6 I will keep as it is. This 10 power minus 6 I will keep as it is. I won't change it. 20 by 0.1. 20 by 0.1. I will do it here. 20 by 0.1. 20. See, 0.1 means 1 by 10. 1 by 10, which is nothing but 200. So the answer for 20 by 0.1 is 200. 200. So 20 by 0.1 is 200. So I'll write it here. 200 into 3.14 into 10 power minus 6. I hope it is clear. See, analyze carefully. Carefully you have to solve. So next I have 200 into 3.14. See, I have 2 into 3, 6. 2 into 1, 2. 2 into 4, 8. So I'll do it here. Okay, 200 into 3.14. 2 into 3 will be 6. 200 into 3 will be 600. So it will become 628. How? 2 into 3 is 6. 2 into 1 is 2. 2 into 4 is 8. Okay, that is when if you have only 2. But since I have 2 zeros, these two decimal places you have to shift, it becomes 628. As a result, your answer for rho will be 628 into 10 power minus 6. Done. What about the unit? What is the unit of this resistivity? Well, for that you have to see the equation. Rho is equal to R into A by L. R is resistance, ohm. A is area, SI unit is meter square. Meter square. By L, L is meter. Meter square by meter. Meter, meter will cancel, 1 meter will remain. It will become ohm meter. Okay, so this is the answer. Carefully analyze it, say it once. Next, we have a problem related to series combination of resistors. Series combination of resistor, one problem, and parallel connection of resistors, one problem. Two problems we will be doing. Okay, let us read the question. Two resistors, 2 ohms and 3 ohms, are connected in series. So you have two resistors are connected in series across a battery of 10 volt. So there is a battery. This is the potential difference of the battery, and two resistors are connected in series across them. Okay, calculate the current and potential difference across each resistor. Just to understand it better, what I will do is I will draw the circuit. Okay, so this is my resistor 1, R1. This is my resistor 2, R2. It is connected across a battery whose potential difference is 10 volt. This is the potential. This is R1, this is R2. So R1, R2 they have given. So R1 equal to 2 ohms and R2 equal to 3 ohms. Fine. You have to find out the current and the potential across each resistors. So through R1 and R2, what is the current? What is how much current will flow through R1 and R2, and what is the potential difference across R1 and R2? You have to calculate. Okay. Now here two things you have to remember. When two resistors are in series, same current will flow. When two resistors are in series, same current will flow. Therefore, whatever current I flowing through resistor R1, same current will flow through R2. Whatever current I flowing through R1, same current will flow through R2. But potential difference will be V1 here, V2 here. Potential difference will be different, but the current will be same in case of series. In case of parallel, it is exactly ulta. Potential difference across each resistors will be same. In parallel combination, current will be different. Okay, so please make sure of that. So R1 is given, R2 is given. So the total potential V is equal to 10 volt. So first let us calculate I, then let us calculate V1 and V2. Okay, let us do that. So first, to calculate I, what I do is I calculate what is the total resistance. So the total resistance or the effective resistance, that is nothing but R. I take RS because they are in series. If they are in series, we have written the formula. It is nothing but R1 plus R2. R1 is given, R2 is given. R1 is 2, R2 is 3. Don't directly write. Directly write the answer. Substitute and then write. Okay. So therefore, RS equal to 2 plus 3, which implies RS equal to 5 ohm. I got RS, done. I got total resistance. So I know what is the total resistance here. I know the total voltage. How can I find I? Again, let me repeat. I know the total resistance here, that is 5. I know the total voltage, that is 10. How can I find I? Which law I can use? Which equation I can use? I can use Ohm's law. Okay. So from Ohm's law, see, from Ohm's law we have the formula, that is V is equal to I into R. But here R is the total resistance RS. Substitute one by one. V I have. Okay. V I have 10. I have to calculate current. RS is 5. Substitute. So V is equal to 10. So it will become 10 is equal to I have to calculate into RS, which is 5. 10 is equal to 5I. I is equal to 10 by 5. Therefore, I is equal to 2 ampere. I is equal to 2 ampere. And since they are in series, same current will flow. Therefore, current through R1 as well as R2 will be 2 ampere. Okay, so this is the first part of the question where you have to calculate the current. Next, we will calculate the second part of the question, that is, you have to calculate the potential difference across each resistors. So here, what is the potential difference? Here, what is the potential difference? I have to calculate. So that I will be calculating next. The potential difference across R1 and R2. So how can I calculate? So the potential difference, I'll write P dot D. P dot D means potential difference across. If you want, you can also take A and B also. It doesn't matter. Okay, A and B you can write so that you know what we have done. Potential difference across R1. Potential difference across R1, I take it as V1. Potential difference across R1, I take it as V1. What is the formula? So I know the current I have found out 2 ampere. I know what is the resistance R1, which is 2 ohm. How can I find the voltage? I use Ohm's law again, that is V is equal to IR. So here V1 will be equal to I, which is a current through R1 into R1. See, very easy to remember. V1 is equal to I into R1. Okay, substitute. So V1 will be I, which is 2, into R1, which is 2. So your answer will be 4 volt. Similarly, potential difference across R2, I take it as V2, which is equal to, so V2 I have to find out. V is equal to IR we already have. So V2 will be I into R2. Okay. So I into R2. So V2 will be I, which is same for both the cases, which is 2 into R2. R2 is 3. So your answer is 6 volt. So 4 volts and 6 volts are the potential differences across these two resistors. How do you know this is correct or not? Very easy. You take your total voltage, that is 10. Total voltage is 10. Now look at the individual voltages, V1 and V2, 4 and 6. When you add, you get your answer 10. This is how you come to know whether your answer is right or wrong. Okay. Last problem we will be solving, that is related to the parallel combination of resistors. Next, we will be solving the last problem, that is problem number 6, which is related to parallel combination of resistors. So this question I have taken from NCERT textbook itself. So R1, R2 and R3 they have given. So 3 resistors are connected in parallel combination across 12 volts battery. So let us draw that. So this is R1, this is R2, this is R3. So these 3 resistors are connected across 12 volt battery. Okay. So V is equal to 12, they have given. R1, R2, R3 they have given, that is 40, 30 and 20. R1, R2 and R3. What is the question? You have to calculate what is the total resistance. What is the total resistance here? R. I'll take RP because it is a parallel combination. Then current through each resistors. So let I1 be the current through R1, I2 be the current through R2 and I3 be the current through R3. What are these currents? You have to calculate. Let us start. First, let me find RP. Now, since they are in parallel combination and we have 3 resistors, let us use the general formula. The general formula is we have 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is what we have. Now substitute. R1, R2, R3 they have given. That is 40, 30 and 20. So it will become 1 by 40 plus 1 by 30 plus 1 by 20. Right. Now what you have to do is, this is 1 by RP. So please be careful. This is 1 by RP. Take the LCM. 40, 20, 30. What is the LCM? Okay, so I'll write 120 because that is the LCM. Okay, please be careful. Now here, what will happen? 120 by 40 is 3. 3 into 1 is 3. 120 by 30 is 4. 4 into 1 is 4. 120 by 20 is 6. 6 into 1 is 6. Okay. Now simplify this. So this is 1 by Rp. So please be careful. So 6 plus 4 is 10 plus 3 is 13. So 1 by Rp is 13 by 120. So this is 1 by Rp. But what I want Rp. So you have to flip it. I have 1 by Rp which is 13 by 120. I need Rp. So you have to flip it. So therefore Rp is nothing but 120 by 30 ohms. So this is what you have. So please be careful. How did I solve it? So this is the formula. I substituted R1, R2, R3. Take the LCM and solve it. And what you get is 1 by Rp. Please be careful. This is not your Rp. This is 1 by Rp. And then you have to flip it. Take the reciprocal. You get this. Okay. So this is the answer for Rp. We got it. Next, what we have to calculate? We have to calculate current through each resistors. I have to calculate R1. I have to calculate I1, I2, I3. But one thing you have to remember, whenever you are in parallel combination, potential difference will be same. Whatever 12 we have, here also it will be 12, here also it will be 12, here also it will be 12. So let me write that. 12 volt, 12 volts, 12 volts. So how can I find I if I know R1 and potential V? I know R1, I know V. How to find I1? Again use Ohm's law. I know R2, I know V, I know I have to calculate I2, again use Ohm's law. Same thing, we will do it. Next, let us calculate the current through each resistors. Okay. So first, current through R1. So current through R1, I take it as I1. So as we know, V1 equal to I1 into R1. Okay, to calculate current through R1, I use the formula V1 is equal to I1 into R1. I1 is the current through R1. So I1 will become V1 by R. Please be careful. Current through R1, if I want to calculate, I will use this formula, which is the Ohm's law. V is equal to IR. V is equal to IR. V is equal to IR. I will be using that. V1 will be I1 into R1. V1 is nothing but this potential. Okay, which is nothing but 12 divided by R. So here R is nothing but R1, which is 40. You can simplify. That is 4 3s are 4 10s are. So this is your current. Similarly, if you want to calculate current through R2, I use the formula V2 is equal to I2 into R2. I have to find out I2, which is nothing but V2 by R2. V2 is nothing but the potential difference across R2 itself, that is 12 again. And R2 is nothing but 30. Again you can divide this by, now this I was able to divide by 4, 4 3s are 4 10s are. This I can't divide by 4, but I can divide both of them by 3. This is nothing but 3 4s are 3 10s are. Okay. Similarly, you can find out I3. Similarly, you can, I1 is V1 by R1, I2 is V2 by R2. What will be I3? I3 will be V3 by R3. I3 will be V3 by R3. When you do that, V3 is nothing but the same potential 12 and R3 is nothing but 20. So this you can divide by 4, numerator as well as denominator. When you do that, you will get 3 by 5 ampere. So this is what you get. This is what you will get. So just quickly see it And with this, we have finished the problem sessions on electricity. So you have to practice. So only with practice all these things will come. So it should be a second nature to you, how to apply formula, where to use, how to simplify all those things. And calculation, you have to be careful. Still, you can write this as 0.3, you can write it as 0.4, you can write it as 3 by 5, which is 0.6. You can do that, you can still do that. But if you keep like this also, it is fine. So if you can simplify, you write it in decimal. But there are some points or places where it is a bit difficult to simplify. In that case, you keep in fractions itself. So with this, I will stop it and I will give my thanks to you. Thank you.